Hi friends, welcome to Answers. So today it is the 94th episode in Space series. So today we're going to discuss about a thing which is kind of weird, which kind of works in space-time. Yes, it's a weird thing, many times shown in many movies. Yes, so this is space-time. And today we're going to discuss about the wormhole. It's an idea from which you can go from one point to another point or even another universe. Yes, from a long tube, like a tunnel which connects all the points. Yes, so this is known as wormholes. Yes, they're like holes which are very long, like worms. So that's why wormholes. Yes, so let's begin. So there are two main kinds of wormholes, which are very similar. So I won't exactly specify both of them. They don't have a big difference at all. The only differences are like quantum things, which is too confusing for you to even understand. I can't even understand it. Yes. So we're going to just say both types of wormholes as wormhole. Yeah. So to basically show, so this is space-time. Take a paper. Okay. So normally space-time does not bend, but just think. It is like this. So this is 3D space-time, which in real life it's actually 4D, but to represent things, we actually use 3D space-time. Yes. So here there are 2 points, point A and point B. Wait. This is B and this is A. Let's use another color. Okay. So here is. So normally to go to from point A to point B, we will go all the way from here, curve there and go back to B. Yes, but that can take millions or even billions of light years away. From the distance between both of the points may be very big, even trillions of light years if that is possible, or even another universe per se. Yes, so but how can we make it shorter? How? By making a tunnel. See, now there's a tunnel where things can fall in from here and go to point B. Yes, that's more faster than this. Which is smaller, this or this? This, right? So that means the wormholes, yeah, they are more easier than the actual route. Yes, wormholes are actually more like point A, point B, and they'll actually connect like this. But to more easily represent that, we'll show it like that. Yes. So to understand real life wormholes, just replace everything here with everything 2D here and turn into 3D, and everything 3D and change it into 4D. Then you'll get how it actually works like, which is very hard to understand and just visualize. So that's why we use like this as the 3D space-time, not the 4D space-time, which I can't even draw. Yeah, it's pretty hard. Yes, so this is practical wormholes. Yes, so there are 2 types of wormholes, traversable wormholes and non-traversable wormholes. Yes, traversable wormholes means we can pass through them without any problems. That means the wormholes are very stable. Yes, so but next one is the one and only non-traversable wormholes. Yes, so these are not very stable. So when you create them, they'll be gone within less than a minute. Yes, so but how can a wormhole be stable? Yes, so there are many. So scientists have proven that wormholes can actually exist in real life. So using quantum computers, which is not like a normal computer, it literally uses quantum things to visualize instead of bits, which makes the computer very powerful. Yes, so using the quantum computer, scientists have proven that wormholes can actually exist somehow using their magic. I don't know how quantum computers even work yeah. So okay, so wormholes can actually exist, but how can we actually make one that is actually stable? So if we somehow make a wormhole like this is wormhole. Just let's call it alpha. Alpha over here is pretty big. Not for scale, but it's actually 1 meter. Yes, let's take it for 1 meter. So it's pretty big. So it starts here and it ends here. That means when you go in this point, you'll then go to here quickly. That's great. But it will not stay for a long time unless you use a thing known as exotic matter. Exotic matter is just matter which is not normal. Things like superfluid, degenerate matter, Raynaud Polaroids, things like that. And there is one type of matter which we need for this instance. That is negative mass. Things with negative mass, if there is gravity, they will go away. Randomly things are 1 kilograms, 1000 kilograms, 1 ton, 1 gram. But with objects with negative mass, there's negative 1 kilograms, negative 1 tons, negative 1 grams. Look at that. There's negative mass. So we need to use that negative mass to keep big wormholes stable. Yes. So wormholes like 1 meter and more bigger. Yes, even like this. These small wormholes also need some exotic wormholes. But there's a size where there is no need for exotic matter for the wormhole to exist. We just need some charged fermions. So these wormholes only need to be micrometers big, smaller than micrometers, that is. So let's call this one a very small wormhole, which is actually less than a nanometer small. So let's call it beta. Yes, it's so very small. For it to be maintained, we only need to put charged fermions. Fermions are basically anything which has mass, like electrons, quarks, and things like that, and even neutrinos. So this can just be stabilized easily. But bigger wormholes need negative matter for them to even exist, which we just theorize about negative matter, but we don't exactly know if the negative matter even exists. Yeah, things like wormholes are pretty confusing. Basically, they're just teleporters. That means we can go through in one side and go out in one side, in another side. Yes. So there are also other theories which state that black holes are the start of the wormhole, and in other universe there will be things known as white holes, which are the complete opposite of black holes. They send everything out. They have a negative gravity somehow. Again, negative things. Why are we including integers inside here? We only need positive objects, not integers. Yeah. Okay. So that is how wormholes work. And if you dive more deeper and deeper, it gets more harder and harder to understand, and your mind will continuously start exploding like big nuclear bombs, which are even more confusing, that is. So yeah, for today about wormholes. Bye.